Oh.
Welcome everyone to today's webinar all about blockchain, crypto, Web 3.0, and smart contracts. I'm of course Paul Asadorian, podcast host here at Security Weekly. My full-time gig, I actually work for Eclipsium as the firmware security evangelist. So I will be asking questions, relaying questions from the chat as best I can. Our subject matter experts for today are Mr. Tyler Robinson is here with us. Tyler, welcome.
Thanks, Paul. Super excited. I'm stoked I get two of my favorite people on at the same time.
That's right. We just tend to Phillies with our favorite people. One of our favorite people, of course, is Beau Bullock from Black Hills Information Security. Beau, welcome.
Hey. Well, thanks for having me, Paul. Nice to be back in the Security Weekly fam for a little bit here.
Right? Yes. Your videos are still super popular on Tradecraft Security Weekly when you were doing that, Beau. So
you know what's funny? It's like I was at B-Sides Tampa like last month, and some college kids from USF walked up to me. They're like, "Dude, I use your Tradecraft videos to pass the OSCP," and it's like it's crazy. Like that was like what 5 years ago or something. It's insane.
It's awesome.
Stuff's still relevant.
Absolutely. So I'll turn it over to you both and let you guys get started and dig in.
All right, Tyler.
Do you guys know where you want to start, or do you need any?
Yeah, I can kind of give a quick intro, and this has been kind of underway for quite a while. Everybody, welcome again. Thank you for showing up, and thank you, Beau, for donating your time and expertise along this. We've been trying to get a kind of a primer on blockchain and crypto and Web 3.0. It's stuff we talk about on the show all the time. One of the issues that we found is there's really not that many security practitioners really diving in on the blockchain side of this and some of the security implications that are actually applying to corporations and enterprises all over the world. And so I've been doing auditing of smart contracts, hacking, blockchain stuff, involved in crypto since the beginning of Bitcoin. And as soon as I heard Beau was doing some stuff, I immediately reached out like, hey, we're gonna do something together at some point, and started passing him some stuff because he's actually doing auditing through Black Hills. They have a whole service around smart contract auditing and consulting around the crypto stuff. So the webcast was inevitable, but this one is really designed to kind of walk our users and listeners through what the blockchain is, what some of the crypto technologies are, how that plays into security, things to keep in mind as you're either buying or selling as an end user, or even thinking about deploying some of the applications within inside of your environment as an enterprise. So we're really just going to walk through the primer, get everybody comfortable with the terms, make it not so black magic and evil and criminal organization activist kind of hackery. We're going to talk through like why it's actually important and why it's really not going anywhere. So you may as well dive in, adopt, and learn what we need to know.
Yeah, I think that's super good intro. So from my perspective, I've been around same as Tyler, since the beginning of Bitcoin, and have mainly been just interested in like hobby, right, for the longest time, just very much interested in it, and started really trying to focus on the security aspects of it 4 or 5 years ago. And ended up starting a podcast, CoinSec podcast, where we just literally every week talk about all the hacks that have happened and all the the various security issues. And one of the things that I've seen over the years is just like the immense amounts of scams that have happened, and immense amount of hacks that have happened, and how that has affected what I see security practitioners' mindsets towards this entire industry, right? And I think that there's absolutely room to be skeptical of a lot of the things that happen in crypto. But I hope throughout today you can kind of see like it's not just all scams. There are some legit use cases out there, and there are people that are trying to build some very interesting tech with blockchain and crypto, and specifically like smart contracts. It's like the way I like to put it. It's like if you looked at hacking like back in the 90s. Like that's where like smart contract hacking is today. It's like it's super interesting, super high risk, and like typically end up being like these multi-million-dollar hacks. Like it's insane. So we have some slides, but I figured we can
really
make this
quick,
more of like
I wanted to ask you
conversation.
Because you do the CoinSec podcast. Did I get that right?
Yeah.
And did you see Joe Grand's latest video where he had to break into a older Samsung
from a
phone.
Trezor, right? Or was it the Trezor one? Or
the Trezor one was his really popular one. It's got like 1 million+ views on YouTube. He did a brand new one where he does a similar kind of thing. He helps someone out, and this person's wallets were locked in an old Samsung phone.
oh, okay,
And
cool.
he did the most amazing soldering job I think I've ever witnessed in my life, like live on camera, to recover the firmware, to recover the swipe code to unlock the phone.
That is awesome.
And he did a
That
great
is,
job. So check it
I'll
out for
check
your
that out. I
podcast
haven't seen
listeners
that one
after
yet.
this
Yeah.
broadcast. Yeah, definitely go Google search Joe Gran or YouTube him. He's got a YouTube channel. It was really cool.
That's
Yeah, that
that
JTAG on that one was crazy. It was so small. Like if you've not soldered onto a smartphone before in JTAG, like you realize the level of skill that went into that. It
Yes.
was hackery, but it was so much skill too.
Yes.
That's awesome. Well, a couple of the slides we'll talk about like hardware wallets in general and just like how to secure your coins and stuff. And while a lot of the hardware wallets have been under a lot of scrutiny, they still have issues, right? So even like the Trezor, like he was able to get into an old Trezor because it had a firmware issue from a year or two ago, hadn't been updated. So all right, well I guess like we can kind of just go through the slides here and see what questions you have, discussion wise, like anybody hop in anytime. So I've got a few sections that I kind of threw in here. First one is just kind of like why blockchain security, like why should we even be having the conversation? Second section, we'll talk a little bit about smart contracts because that tends to be kind of like the root of where a lot of the issues are right now. And also like if you really want to get into like some crazy bug bounties, like smart contracts is where it's at right now.
It's amazing how much money is in auditing smart contracts, right? And there's really not that many people doing it that are really good at it. But you start to think about smart contracts, and we'll cover the immutability of those smart contracts. You deploy code and you have a smart contract with a bug in it. Those bugs can lead to millions or even billions of dollars in loss. So it's not uncommon to see $1 million bug bounty for something that's actually a really good smart contract fine. So keep that in mind if you're trying to figure out if this is a lucrative business to get into.
Right. So it's crazy, like, because like, all of us have been in traditional InfoSec for years, right? And we've seen like the bug bounties for like Microsoft and paying out like 50 grand or 100 grand. You're like, wow, that's a big bug bounty. But the majority of these these bugs that are found in smart contracts are like $1 million minimum bug bounty. Wow. It's insane. Yeah. All right, so common Web3 attacks. We'll talk about some specific code flaws that are common. We'll talk about some of the social engineering aspects because we still have like the Web2 risks a lot in just the blockchain space as well. Key compromise. So like you just said, the ability to recover from a phone, like that's a risk, right? Like having that ability, somebody steals your phone and then somebody is able to solder on and get the swipe code and get into your wallet. That is definitely a risk. And then at the end, I've got some resources to leave you with if you do want to go on this journey and try to get into blockchain hacking yourself. So this is us. We've already been introduced, so I don't know if Tyler, you want to say anything else?
No, I mean Beau's awesome, so just pay attention.
Oh, whatever, man. I've been at Black Hills for 8 years. And just mainly pen testing, red teaming. And then as of like a year and a half ago, I have started primarily focused just entirely on blockchain security and cloud assessments. So
I've been trying to convince Sean over at Trimark to help us build a blockchain application to secure Active Directory. He's still not on board yet. But.
Dude, Web3 auth, man, that's definitely that's where it's going, man. All right, so short history blockchain. So 2009, Bitcoin launched, first public ledger transactions using blockchain. So throughout today, you'll see a few different applications other than just cryptocurrency, right? Like that's a lot of people see like cryptocurrency and they're like, well, why should I care about that? Like I'm not interested in the monetary side of things. But blockchain is a lot more than just cryptocurrency. So Bitcoin was the first one, right? Like that was when like cryptocurrency became a thing. In 2015, Ethereum launched, and this is when smart contracts got added in. Now, I know, Paul, when we first talked about this, you're like, I thought a smart contract was like a legal document.
Like a DocuSign. That's when I heard smart contract. I think that's what they used to call like a DocuSign or those other kind of things.
It was a
It's like
flow.
I
You
heard it
signed the
from
DocuSign
Laura
and it flowed.
until I stopped you because I'm like, wait a minute, what is a smart contract?
Yeah, so it's a little different. So smart contracts, they're really just programs. It's just a piece of code that has been deployed to the blockchain that you can interact with. Why it's called smart contract? It's a bad naming system, I think. But realistically, like I think the naming convention kind of came from the idea of it is an immutable contract. Therefore, it is a piece of code that you can't change, and that creates this, context where you have a contractual nature when you interact with that piece of code.
I think that was one of the biggest like hurdles for a lot of people to get over, was that just the wording of what smart contract was. I explained, like, just like when you do an escrow, right? You pay your money into an escrow for a home, you end up having the escrow do certain things. The money makes it in there. The escrow pays your insurance, it pays your premiums, it double checks and ensures that the interest is compounded. All the back end code that happens on a mortgage, it's the same thing for a smart contract. It's just all digital immutable code that's tracked and monitored, that does smart things based on actions in the real world. Those are the real important pieces of why smart contracts actually matter. You start to think about where that applies to your daily life, and really smart contracts are integrated into more things than people realize already.
It's true. Yeah. That's you'll see, like, as we kind of get up through the timeline here, like how more and more things have started implementing smart contracts. And then the second really big thing that's happened, after smart contracts got deployed, were the first decentralized applications. So decentralized application, the whole idea of this is like, I guess like a really good example of this would be if you've ever used like a standard real world bank, right? Like that's your centralized bank. They control your funds, they control everything, right? Like you can go there, you can take money out, you can put money in, but at the end of the day, it's all sitting at a centralized entity. A decentralized application, the whole point of it is that it's spread out across thousands of nodes, and whenever you interact with it, there's no centralized place that can actually stop that transaction from happening. So a decentralized application, DeFi is one of the topics that we'll talk about, decentralized finance, where the whole idea is that you have a smart contract that you can interact with over the blockchain that synchronizes your transactions across the blockchain without you ever needing to actually interact with a specific single entity. Like technically, like I have an Ethereum node at my house, right? And Ethereum nodes they're just pieces of software that download the blockchain and they sync it up with all the other nodes around the world. Think like kind of like almost like a P2P kind of situation, right? Like where you have this synchronization happening between all of these computers at the same time, where they all store the same database and they validate all of the transactions that have ever happened, and make sure that they're all the same. So anytime that I would want to not go through a centralized entity, I could go directly through my own node here at my house, right? So that's one of the kind of the more interesting applications that have happened in the blockchain world too. And then so modern day, so one of the things that like Tyler was talking about is like how it's become more and more relevant and becoming more and more in use by other entities, right? So we've seen actually here in Florida, we've had I think like 3 or 4 houses sold as NFTs. Like the contract of the house was sold as an NFT. Supply tracking. So I know Walmart has been using blockchain for supply chain tracking. Things like avocados, right? Like, you can track like where it came from, like the farm it came from, right, on the blockchain. Digital identity, this is a big one, right? So IAM, typical like cloud IAM, like identity management. This is something that, you can now try to tie an identity to a wallet, right? And so I can go and I can say like, okay, this is my public key that's associated with me. I go to a website, I log in with my private key, never need a password, never need username, anything like that other than my private key. And because of the history I have with the blockchain, because of everything that has happened that I have done before that point, can be transferred, and my identity can be basically just known and based off of my public key.
I really hope that one takes off, honestly. Like the more we talk about that, like the implications of being able to do something like blockchain voting, where you have an immutable record of all of the votes, the cryptographically sound, the ability for people to have that public-private key signing with inside of it and an identity associated to it. I mean, it's like Estonia's digital identity. It solves a lot of problems that we're running into. It is the fear of that moving forward. I think a lot of people are just scared because it's tied to crypto or it's tied to blockchain. Like that's all been associated with criminal activity in the early days because of the anonymity that most places were thinking they were getting from the blockchain.
Yep. Yeah, I like how you put that thinking you're getting it, because that's one of the bigger myths that has kind of been debunked now, is that it actually is very much trackable in most cases, right? And a lot of the tooling around tracking transactions has gotten so good that it's made it so much easier to track like where funds are coming from, where they're going. Like, to give you examples of like a lot of the big hacks that have happened, like the way that they end up tracking people down tends to be where they have either funded a wallet from a centralized exchange so that they can actually carry out the attack, or they've cashed out of a centralized exchange. Because at the end of the day, there's still not a whole lot of places that you can just go to and say like, oh, I have $1 million of Bitcoin, give me cash, right? So at some point, an attacker who steals money, even ransomware, right? Like, so if somebody has a ransomware payment of like $5 million, right, in Bitcoin, what are they gonna do with it? They have to go to an exchange and cash it out, right? So in order to do that, most centralized exchanges require KYC now. So know your customer. And that creates a place for law enforcement to go and say, okay, who is the wallet tied to this address? You have KYC implemented. Provide that information to us. So,
and there's always that exit node. That's kind of the big caveat that people don't realize. Like, even if you're using a wash, like everyone talks about washers and the laundering and funneling of all these cryptos, chain analysis and many of the other crypto places that use these very smart algorithms and some ML and AI to kind of track through those washers and follow those transactions. They almost always lead to KYC where there's an exchange that outputs money. Like, if you're talking anything over a couple $100,000, it's not that easy to get that money out. Like, theoretically, we've tabletopped this with a lot of places, and to get $5 million out of any given place, like, you're talking about a pretty heavy lift from an exchange side. And you're going to pass through an exchange, so you're using mules or cutouts or things of that nature. In fact, Conti, when we got into a couple of their chat servers, one of the big revelations there was they were working with a place, and they were actually working to stand up their own exchange in order to be able to leverage those funds and comply or not comply with certain regulations as the exchange, or providing information for certain things. So you start to think about that, and if you're an APT or nation state, like 100%, they're probably working with the exchanges, or they are an exchange. So you really have to think about where your money's going out. This is not anonymous anymore, and there's no easy way to funnel it. So it is still pretty safe.
And so, like, there's been a lot of examples that we've seen over the last year and a half, which I'll talk some about that in a couple slides here too. But where, like, to give you some of the bigger cases, right? Like, there was an attack that happened right at the end of 2021, where it was $600 million stolen from an exchange, or from a smart contract. Now, if you're an attacker and you have $600 million of Ethereum, like, what are your options, right? Now, to kind of piggyback on what Tyler was saying about mixers, right? So mixing services are a thing. Like, that is absolutely a real thing, where you have these services that the whole point of them is to try to wash the transaction records. But at the end of the day, because everything is still tracked on the blockchain, it's not foolproof. And more importantly, the thing that makes it much more harder for attackers to use washing services is the fact that most of like the mixers that exist today don't have an insane amount of value locked in. So to give you perspective, like the primary mixing service that literally like every hacker uses, right, is called Tornado Cache. And now this site is, the whole point of it is to have like a privacy centric way of making it so that your transaction history doesn't really exist anymore. And the way it does that is it has a pool of funds. And so there are users that can put in like however much ETH they want into this pool of funds, and they can actually gain like a margin off of it, basically, by having it staked. And by having that value staked there, it creates a pool that all of the coins can kind of get, you know, mixed together in this one pool. Now, the problem is that total lock value is like around $30 million max. So if you steal $600 million and you try to wash $600 million, it's very, very easy to see where that money goes out of it. So like if I put in $100 million and, you know, I take 50 million out the other side, it's very easy to see where that went. So that's one of the bigger problems with like washing services and why it is possible to track a lot of this stuff. So speaking of why, so some of the hacks that I like to kind of bring up here. So this is why I think that, you know, us as security professionals, we should actually, you know, be interested in this and try to help, right? So centralized exchanges alone. So if you think about Coinbase, you think about Binance, you think about a lot of the places that you would go and you would trade actual like fiat currency for crypto. Over $2.5 billion stolen since 2011. When it comes to smart contract hacks, 1.2 billion stolen in just 2021. And like, you know, like it's easy to like see those numbers and just be like, you know, like it's just kind of like, okay, well, it's all made up money anyway, right? But you know, a lot of that actually comes from fiat currency at the end of the day that has been put into crypto. And then just 2022 so far, over 1.5 billion stolen. So just up to right now, you know, like that's a lot of money stolen from smart contracts.
Yeah, that's all real money. Ask the guys in Dubai that are losing some of that big money.
Yeah, right.
They're very serious about getting their money back.
Yeah, and then just consumer wallets alone. So like, you know, your everyday, you know, normal people, millions of dollars lost through social engineering, remote exploitation. A lot of that comes down to just an education problem, right? Like not knowing how to use this stuff. Because I mean, sometimes it can be complex, you know, like actually knowing how to set up a wallet, how to send transactions, how to know who to trust on the internet, basically, like all the same Web 2 stuff we worry about, you know, in general, right?
That's the same issues we're running into now, right? Like complexities of integrating systems between, you know, multiple things, hardware, software, APIs, exchanges, all of those chains of events are where we end up just with, you know, everybody has it on their phone and they just use it. It's fun.
Yep, exactly. So why so many hacks? So blockchain is still in its infancy, right? Like it's still an emerging tech. It's still a thing. It's a thing that people are trying to figure out and trying to understand how does it even work, you know? And the biggest problem is that you have this emerging tech. You have all these, you know, VC funding people that are trying to build new software, they're trying to build new products, and they want to be first to market, right? And the problem is that because it's such a high risk play, that being first to market is usually like, you know, like you're the first one you're the front of the attacks, right? You're at the forefront of the line of, you know, the hacks that are going to happen. And you know, traditional security protections tend to be an afterthought. And you know, we're talking about traditional web API stuff, looking at traditional like server management, right? Like we've seen. So there was a hack on something called Ronin Bridge a few months ago, and this is another like $600 million hack. And the way that it happened is server compromise at the end of the day, and it's because the chain that Ronin Bridge uses required, I think it's like 5 of 9 keys to send transactions. So it's a multi-sig kind of situation where you have to control 5 wallets. Now, 4 of those were all controlled by one entity. And the other one, you know, it's probably a similar exploit that they managed to get on the whoever server, right? So.
Hey, there were some questions, Beau and Tyler.
Oh yeah.
Maybe it's an opportunity to kind of back up and talk about how passwords, keys, and wallets kind of interact with each other. So a little bit of kind of a, you know, intro to some of that technology.
Yeah, absolutely. Tyler, you wanna do that one?
Yeah. So I guess a couple different ways to think about it, and Beau has a couple slides on some of this, but a couple things to think about, and there's some questions around like how do these wallets get compromised, or if a computer is compromised, like how does that lead to the compromise of say something like a wallet or an NFT. When you start to think about what these are, you're actually talking about files. At the end of the day, this is just information. You're talking about private keys and public keys. So when the
So like
storage
basically
of
a lot of this hinges on Diffie-Hellman, right? It's a foundation for some of the blockchain technologies is implementing a form of the Diffie-Hellman.
it depends on which one you're using and which like which blockchain and like how they've implemented the crypto, but essentially if you think about it like Diffie-Hellman, yeah, there's public and private keys. You're using it's not Diffie-Hellman, but it is leveraging that public private key kind of mantra.
Concept. Yeah,
Yeah,
sure.
so you think about where those keys are stored and you start to think about things like your phone, where you have a file on your phone or a wallet app that is managing your private key, or even a web browser extension that has your your private key for buying and selling crypto, or using the extension to pay for something with crypto. All of those things are leveraging your key. So at the end of the day, if your phone is compromised, you get a a text message, you click on a link, your phone's compromised, your browser's compromised. What the attackers are looking for is the ability to steal that wallet or that address or that private key from those applications or wherever or however they're being stored.
Now much like most keys in this sense can be protected with a password, does that also apply to keys used in cryptocurrency?
Yes, there's things like your passphrases, which is your secret code to unlock that, which is one mechanism. Many of these implement a proxy application layer that allows you to use something like your Face ID or a swipe scan in order to unlock that, which is not leveraging your smart seed password, but rather a proxy to open that vault where that key is then able to be utilized. And so you can kind of start to think about the attacks in the traditional ways that if your browser's compromised, your computer's compromised, your phone's compromised, the applications underlying, if you don't have things like hardware tokens, hot wallets, cold wallets, those things that are having that layered defense or mechanisms for the access to your financials, then you're in a lot of trouble. Yeah, NFTs are going to get stolen, your wallet's going to get stolen. And we'll kind of cover some of that more as Beau walks through, what each of these attacks are, and like not just smart contracts, but wallets themselves, and how those kind of play into the whole ecosystem. That's where it starts to make sense.
Yeah, and on the wallet side, there's a few different ways to generate wallets, and I'll show a few later on today. But in general, you have software wallets, like Tyler mentioned. So this would be something that's just stored on your phone, on your computer. There's hardware wallets, which they're almost like USB devices in most cases, where the private key is actually stored on the device itself. And so anytime you want to send a transaction, you actually have to implement a connection between the hardware wallet and whatever application you're trying to.
Almost like a TPM. If you think of it like a TPM, that is the keys themselves are actually stored on hardware with inside of it that require unlocking or accessing.
Yep. So this is one of my favorite slides to talk about, because this kind of I think helps provide the big picture, right? So we've talked about smart contracts a little bit so far, but there are so many elements to this whole ecosystem that need to be looked at, right? So first off, the layer one, right? Like this is the underlying blockchain. This is where your transactions are actually, resolved at the end of the day. This is where, if the underlying blockchain got hacked, like it's just like everyone's screwed. Like there's not a whole lot you can do about it. So
there hasn't been very many of those. Like I think there's only been one very recent one on the Ethereum side of that, and it was disclosed and properly patched and forked very quickly. So
yeah, so whenever you look at how blockchain works, there are pieces of software at the end of the day that are running on computers somewhere that are syncing the nodes. So to give an example of Bitcoin Core is the most popular piece of software out there right now for the Bitcoin network that syncs all the transactions, puts them in your local ledger. And then Geeth on the Ethereum side is one of the more popular softwares there. That's what I run here. And Geeth, so this is where vulnerabilities can come in to play, right? So the one in Geeth happened last year, where somebody was able to submit a transaction that created a fork. And now a fork is basically when you take the transactions and you cause the nodes to start mining in a different direction. So you basically create like a separate blockchain, so to speak. So another really popular attack that you hear about a lot are what are called like 51% attacks. And that's where if you can control 51% of the network, you can do things like potentially do double spending types of attacks and modify transactions, that kind of thing. Layer 2 is something that it's been around for a while now, but it's something that a lot of people don't realize is a thing. And this is something that developers of various blockchain technologies have tried to implement to make things more efficient, basically. So the whole idea is that you have, like, let's say you have your underlying layer 1 Bitcoin network. Super slow, right? Like, so if you try to send a transaction on Bitcoin, it takes minimum 30 seconds to, could be up to like 30 minutes sometimes. Very slow. So developers are like, all right, well, we got to build something faster. So they built Lightning Network, which is a layer 2 solution which goes on top of Bitcoin, and Lightning Network transactions are super fast. But it's basically like this kind of like abstraction layer where ultimately all the transactions do end up getting resolved on the layer 1 blockchain, but they're much faster on layer 2.
Yeah, to put that into perspective too, like to understand, if you think about traditional financial networks, something like MasterCard's networks, you're talking about upwards of 5,000 transactions per second. And so that transaction speed is where there's a lot of financial institutions looking for lower cost transactions that are just as fast or faster in order for the processing. So they're not doing a lot of the batch processing. They've got instant fund validation and verification. Those are the reasons that you're looking to get the speed and the ability to process the bulk of those transactions very quickly.
Yep, and then so now smart contract. This is like the software layer on top of the software layer. So you have this blockchain layer, right? Like, which is layer 1, where you have Ethereum, which is in fact a software, right? And now you have software that can be deployed to that network as well. So what's fascinating is with Ethereum, the way this works is what's called an Ethereum virtual machine. Now, anytime a smart contract gets executed, it actually gets executed in this virtual machine that is part of the underlying blockchain software. Now, these programs, they're automatically executing, meaning that if I send a transaction to a smart contract and I include functions and parameters like, let's say that I wanted to deposit a token into the contract, it's completely autonomous. There is no central authority that can change the logic of that contract. There are some examples where you can create what are like these like pseudo kind of like proxy contracts, which in those cases you can create somewhat upgradable contracts. Still something that is being explored. And then, sorry, I saw a question here. Brings back to a question on proper backup, especially if you use a USB device, like mentioned with hard-coded access. Yeah, so on the backup topic, sorry, we're backing up a little bit here on the back to the wallets. So on proper backup of your wallet, now there's a few things, right? So when you go to set up a wallet like MetaMask, which is probably the most popular extension, crypto extension that a lot of people use, there's a mobile wallet for it. Whenever you set that wallet up, your keys are going to be stored on the device, right? So that like that when you go to send a transaction, it can access those keys. Now, whenever you set the wallet up, though, it will provide you with what's called like a mnemonic recovery phrase, which is a set of 12 words. Now, pretty much every blockchain has this way of generating wallets built in, and it's kind of fascinating. So basically, you have a list of 2,048 possible words. Okay, now that list gets generated into a sometimes 12, sometimes 24 words list, and that is effectively like your backup code, right? Like, so if you think about like whenever you have like Gmail set up, right? You have your backup codes, and if you lost access, you lost your password, got locked out, you have your backup codes, you can get back in. Similar kind of concept. So if you ever lost your device, or if it was destroyed or whatever, and you have your backup codes, you can recover your wallets, right? And this is something that, absolutely has to be protected at all costs, right? So, recommendations here tend to come down to write it down on a piece of paper, store it in a lockbox somewhere. What I usually recommend doing is there are a few steal devices out there that you can order off of Amazon. There are these, they're fireproof, where basically you can store your recovery phrase on these devices that are completely fireproof. And in the event that you lost your wallet, you can recover it.
Yeah, they have they're like metal cards that you can actually slide in and screw in your phrases. They have the phrases on little metal devices. There's 12 slots. You slide it in, you put your phrase in there. If it started on fire, like that's a piece of metal that's got it engraved into it, and those phrases are combinable, and you just put your phrase onto that. But that being said, a lot of people, many of the hacks that I've seen is people's computers are compromised, phones compromised, browsers compromised, or even their single sign-on password vaults, where they store their backup seed phrase into a password vault, something like LastPass or 1Password. Those are all great ideas. Keeping your passwords safe and stored in a central location is a good idea, but that relies on the security of that and the browser extension, the browser security in your computer. If you lose that and those phrases are in there and your seed phrase is compromised, your wallet's gone. Anybody else can recover that wallet in the same way that you would be able to.
Yep, and so the big difference there is, right, like if, let's say you compromise my computer and you got my bank password, right? Like you might be able to transfer out of my bank, but at the end of the day, my bank actually has like the ability to, detect fraudulent activity and do something about it, right? When you look at crypto, there is no, central person you can go to and say, hey, I was hacked, so-and-so stole my crypto, give it, can you help me? So that's why it's completely never a good idea to store it digitally at all, your seed phrase. Because in the event that somebody does compromise your computer and they steal your seed phrase, just like Tyler said, they can back up or restore your wallet and then just transfer out of your wallets to their own, right? And then it's just gone. So
there's no FDIC backing. You won't get that money back. There's no insurance. Like it is gone when it's gone. That's why you end up hiring professionals to go after people that steal those kind of things.
And this actually leads into hardware wallets, right? So like I said, like hardware wallets, the cool thing about hardware wallets is if you compromise a PC where somebody's doing transactions, you could potentially, do lots of stuff, right? Like you could, make fake transactions, you could do a lot of things like that. But at the end of the day, they can't just directly transfer your wallet out, right? If it's on a hardware wallet. It requires you to actually do an interaction with the hardware wallet directly. So it's a much safer approach to doing anything in the crypto realm, is to always operate from a hardware wallet. Mining software. So actually, Tyler, you want to talk about mining software? I know you that's your avenue, right?
Yeah, absolutely. And this is one that is heavily debated right now because we're in kind of the middle of a transition where you have something called proof of work and proof of stake. Many of these blockchains are leveraging proof of work, where there's cryptological transactions happening, which is usually where graphics cards come into play, or specific ASCII miners, something like the bit ant miners, or any of the miners that are specifically there to do very specific mathematical calculations. Those are what is used to calculate the validity of the blockchain and validate those transactions. Well, there has to be things to do that, and there has to be X number of devices to handle those transactions. That's where mining comes in. People have miners set up in pools of these mines that allow you to send the transactions from the blockchain, have it do the calculations, and once a pool hits that calculation, sends it back, the validations happened. Well, that takes power, that takes devices, that takes a lot of money. When you talk about mining, you can be upwards of, any good mining operation can be 5 megawatts to 100 megawatts. Most of the stuff I was deploying was 100 megawatts. That's a lot of power. That's entire states of power. So those are very difficult to stand up and do at scale, and so they've kind of moved to this proof of stake, which is where we do validations, and there's a lot less power utilization in the calculations, and there's more of a sub layer on top of that is handling the calculations of these and passing those back to the block. Or things like Solana, where you're doing even more, where you have a node and you're doing validations across RPC networks that are very, 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 very quick, much faster than the traditional, send it off to the Bitcoin block and do the calculation. So all of these different blockchains leverage different validations and how they validate, whether it's proof of stake or proof of work. And that comes to where you get into the mining ecosystem of how much you're getting paid for mining these transactions, how many people are actually doing the mining, what it's actually worth on the blockchain. There's a whole economic side of this that mining comes into play, and it's it's very fascinating, very lucrative at some points in time, and not so much in other points when you talk about how much power utilization, what power costs, and what mining operations cost. So thinking about that and finding someone that's done it before to make sure that actually makes sense for you is one thing to consider. And there's additional pieces to that when you start to talk about exchanges, and Beau's going to get into the custodial versus non-custodial. And again, we go back to the wallets and keys. Who's storing your keys, who's doing your calculations, and where are these transactions actually being centralized into? And that actually matters when you're talking about how you're doing your different contracts.
Yeah, and so to answer Kerry K's question real quick, so he says, or they say, is proof of stake simply a way to make the rich richer? can only participate if you have the stake money to begin with. Well, what I would answer that with is, currently, if you have the money to buy mining power, then that's it's no different than buying mining power like you would now, right, Tyler? I mean, does that sound accurate?
No, yeah, that's 100% right. Like, I mean, again, to get a sustainable operation for mining for proof of work, you're talking about standing up a 5 megawatt operation. You're talking about hundreds of millions of dollars in just mining rigs, getting the transformers, actually doing the power properly, getting the cooling set up and done well, having the ASCII miners managed and pushing to a pool properly, and the security of those things. So the proof of stake seems to be a more effective way to distribute that and dice that up into smaller increments, so that there's not such a reliance on A, the power grid, and B, the people that have the money in order to get the larger operations stood up, where the pools actually start to throw off the differentiation of what's being mined when. And that does matter. So I think the proof of stake is the right move. However, we won't see the proof of work go away anytime soon. I mean, you're still probably 5 years plus out just because of what's backing and how much market capital that Bitcoin still has and will have until they fork and move to something different.
Yeah, and I think so. The other thing, around this topic is I don't think Bitcoin is even looking at proof of stake currently, right? I mean, Ethereum for sure is ETH 2.0 is like coming in the next couple months, where that's going to be.
And they're pushing that hard. That ETH 2.0 is being hammered.
And there are I guess some conversations around like security, right? Like when it comes to who can or to which network's more secure, right? Now, from what I've gathered, and this is just from articles and stuff I read, a lot of people say that they think that proof of work technically is a more secure way of validating transactions. I don't know. What are your thoughts on that, Tyler?
I think it is, to an extent. I mean, you kind of run into the same problem. I think people take the big picture look, but they don't actually go big enough. You start to think about where the validations happen for proof of stake and who's actually staking. And if you're able to have such a majority control and obtain a large stake across multiple staking pools, and you do that very strategically, yeah, you could affect a couple timing attacks. You've got some race conditions that you can abuse. And I think the security side of that, yeah, has some implications that I don't think are fully vetted. I think it is a better way to move towards, but proof of work, you kind of have the same issue, right? You talk about the pools that are actually doing the mining and who controls those pools, the number of pools, how they actually can fluctuate on verification and availability. If you're managing large scale 100 megawatt pools and clusters, then if you took the availability down and forced the stakes up and start messing with the validation numbers, then yeah, there's still kind of the same issues you run into. I think there are different security implications from both sides, but I would argue that they're probably, from a big picture, they probably are thinking about like nation states when there's phishing attacks going on.
Mm-hmm. Yeah. So we definitely derailed on this side a little bit, but
Yeah,
so mining software, and then centralized exchanges, which we did talk a little bit about. So like the whole idea of like being able to hack centralized exchanges, that's we'll talk a little bit more about that later too, where we say, we talk about like the whole idea of not your keys, not your coins, which is a phrase that gets thrown around the idea of if you don't control your private keys, if you don't have a hardware wallet, if you don't have you're fully in control of that set of private keys, then if an exchange gets hacked, same thing, it's just gone. With decentralized exchanges, this is where we have seen a lot of the smart contract hacks over the last couple years. So DeFi, it's a major target right now. And then people at the end of the day, right? So social engineering, rug pulls. So rug pull it's a scam at the end of the day. Like that's basically what it is. Is like where a project will try to get investors to invest in it and then just disappear with the money. That's a rug pull. So that happens too. And just in general asset protection, like how are you storing your keys? All right, let's get moving through here. Actually, hey, Paul, how much time do we have? Like, is there like a time limit at all, or?
I think we set this one for 2 hours.
2 hours?
So I think
okay,
you guys,
cool.
Yeah, have a little over an hour left.
Okay, sweet. All right, because we're definitely a little behind from what I was thinking.
We're derailed everywhere.
All right, cool. All right, so all right, smart contracts. Now, I have a quote that comes from a book called Mastering Ethereum by Andreas Antonopoulos and Gavin Wood. Now this is just a snippet of it. It says, once you launch your code, there's little you can do to fix any problems. And this phrase actually gets expanded upon a little bit more. And my favorite analogy is if you think about traditional software development life cycles, the phrase move fast and break stuff is like that's like the catchphrase, right, of most developers' life cycle. Like move fast, break stuff, because they want to be able to push things. And 90 minutes by the invite. All right, we'll try to make it 90. We'll see how that works out.
We got there.
So in crypto, if you move fast and break stuff, you lose $5 million, or you cost your users, your user base, a lot of money by a single line of code that's wrong. So when it comes to smart contracts, this is something that is not just Ethereum specific either. They're technically smart contracts on Bitcoin too. Nobody really uses them. And then there's smart contracts on a lot of the other networks too. So Cardano, Solana, a lot of the other networks have smart contracts as well. These are computer programs that just don't change. They are pieces of code. They get deployed to the blockchain, and whenever you interact with it, it does something that a piece of software would do. So in this case, this is just decentralized execution. So whenever like this example here, we have an example of a piece of code that is a smart contract. This is a vending machine essentially, and this contract would get deployed to an Ethereum address. And then if I wanted to interact with it, there's actually a number of ways you can interact with it. You can interact directly via like the blockchain, so like sending RPC calls to a node. You can actually send curl requests to certain API endpoints as well. So a lot of the traditional API style attacks can apply in some of these cases where you're doing fuzzing of parameters. So like in this example, there's a function refill right here where it has a unit amount. So the amount would be like the parameter that you would supply to a refill function. So you would be basically sending a request of sorts, right? It's a transaction at the end of the day, but it's from an API perspective, it's a web request, right? Where you're sending a web request to a parameter on a contract address, and then sending it a value, and then depending on what the value is, the rest of the code would do something, right? It's just a piece of software. Now,
I think that's the big difference that developers have not, like traditional developers have thought, oh, this is just simple Python-like or C++-like code. Like I can just write the code. They're not taking into account that there's very stringent monetary actions that this code doesn't change, and so you're more engineering and being very specific. I think you're onto a point earlier that you didn't finish because it was on your last webcast, but rather than developing code, you're doing more like space or aeronautic engineering, where you have to be very specific and stuff has to last. And I think that was that was one of the best things that you said on your last webcast, was around how you develop has to change without the breaking side of it.
Yeah, it's like launching a spaceship, you know, like, I mean, like once you launch it, you better hope the wing doesn't fall off.
You better hope that code is running on what it's supposed to be running on, because there's not a firmware update that you can just push magically.
And I can promise you there are a lot of very, very highly technical people trying to find these vulnerabilities all day long. And they're finding them, and they're exploiting contracts for millions and millions of dollars. It is a reality, and it's something that it comes back to what I mentioned about how you have all these organizations trying to race to be first to market. So what'll happen is, let's say that I'll like Tyler and I want to start a new marketplace, a new NFT marketplace, right? We're gonna go sell some NFTs, and we write some code, and we say, oh, it's working. We better get this out there before the next marketplace launches, so that we can beat them to market, right? Like this is how the blockchain world is right now.
I'm minting my 0 days. Those 0 days could get just closed or patched real quick. So we got to get to market fast, man.
Yeah, and what will happen is we'll deploy, and sure, maybe it survives for a month or two, but because the code cannot be changed in a month or two, all the NFTs that have been stored in our contract, or whatever funds have been put into our pool that we made, or whatever, because we made a coin, maybe we made a coin that users can get if after they transact so many NFTs. They find a vulnerability and everything's just gone. Like it's literally like a blink of an eye in most of these cases, where a single line of code in these smart contracts like this can completely devastate an entire project.
And the project may be valid. It may be a great project. It may have a ton of value, but because the code itself, because those are getting deployed as bytecode to a blockchain that is backing that project, if that is done incorrectly and there's a vulnerability, you've now broke that project. And that is simply from the code. It's not necessarily the project's bad or the blockchain or the crypto side of that is bad. It is because the code that is managing that DeFi app or whatever you've done with it is bad. That actually breaks entire ecosystems and projects that have big funding behind them.
Mm-hmm. Yeah, and what's kind of interesting to think about here is that in the traditional like web API sense, like there's always like a server running somewhere, right? Like you have like this server running, and then you could interact with it and something could happen. In the blockchain context, these pieces of software only ever do anything if you send a transaction to that contract. So it does actually take like an actual transaction to occur for the code to actually execute. Otherwise, it's just dormant in a database somewhere. So Solidity is the main language for most smart contracts. It's not the only one. There are a number of other languages as well, but Solidity by far has the market dominance when it comes to smart contract language. So when you're looking at hacking smart contracts, Solidity is the one to learn right now. It is a similar to JavaScript in context, which actually kind of goes hand in hand with a lot of the applications, a lot of the Web3 applications that rely on contracts as well tend to be JavaScript based. And that's just because there's a library called Web3.js, and that's like the main one pretty much everyone uses. It's a Web3 JavaScript library that enables you to implement the ability for a wallet to send transactions through a web app. Now, you can get really, really deep when it comes to decentralized applications. So, the majority right now of like Web3 applications are kind of like a hybrid. They're like a Web2/Web3 application, where you have Web2 front end, and typical web app that people are interacting with, Web3 JavaScript that's running, where it has the ability to implement connectivity between your wallets, which in most cases is browser extension, like MetaMask, and then ultimately being able to send those transactions or at least initiate the transactions, because at the end of the day, your wallet is really where the transaction is going to end up sending from. So to give you an example there, let's say that I want to use a decentralized finance app to trade Ethereum for like sand token or some random token, right? Go to the application in the browser. I click transfer. What'll happen is the Web3 JavaScript code will actually pop up a transaction for me to sign. And then once I sign it, what's actually happening from that point on is the web app doesn't actually have anything else to do at that point. What happens is, because I'm signing a transaction on my wallet is going to connect to wherever I have like the node set up, or in most cases, it's using an API currently. So right now, Infura is one of the main APIs that most MetaMask wallets are connected to. And whenever you go to send a transaction, it just sends a web request and a transaction to Infura's API. When you're looking at actually writing code, really easy way to just dive right into it is Remix IDE. So remix.ethereum.org is a web-based IDE where you can edit code, and you can actually deploy from it too, which is super handy. So you can deploy directly to one of the networks. So with Ethereum and with pretty much every other blockchain, there are test networks as well. Because if you were to go and try to like deploy your code to mainnet on every single time you had an application you wanted to test, it gets very expensive, very, very expensive. So there are all these test networks you can connect to as well, and then deploy code there, and then make sure your application works, and go through the process of interacting with it from Remix. One thing that's kind of neat is, so when you write code in Solidity, what ultimately happens is it gets compiled down into bytecode. And then that bytecode is what actually ends up getting stored on the blockchain. So if you actually go look at an actual, like the storage for a contract address on the blockchain, it's all bytecode, which is, it looks a lot like just hex. And natively, if you just went and tried to decode that, you can get a little bit of a glimpse into what's happening in the contract, but you won't get the exact, function by function, exact language that was written in the contract. Now, a lot of, or some of the blockchain explorers, such as Etherscan, which is one of the main ones for Ethereum, have implemented this ability for you as an author to go and verify the code that you actually publish. And what will happen is, like, if let's say that I have a marketplace and I have a contract. I could go to Etherscan and verify the piece of code to the bytecode, so that when people go and look at the contract, they can say, oh, this isn't actually doing anything malicious. It's kind of like an open source way of doing software development too. I would say like 90% of legit smart contracts out there all have verified code that are just posted on the blockchain.
Yeah, and the Solidity is one of the biggest ones, but remember there's 1,800 different altcoins or blockchains out there now, and so each of those utilizes something to do that, and that may be something like Selena and Rust or Solidity. All of these things leverage different compilers and different code bases in order to implement and deploy their smart contracts. So when you look at that, you really have to understand the specifics and nuances between each of those blockchains and know what you're actually looking for.
Yep. Yeah, and since, like I said, since the code is public, anyone can analyze it, and this is why, like, it's also really, really
important. That's good and terrifying at the same time.
It's good and bad, right? Because so on the good side, as a consumer, you can go check it yourself, right? And make sure that it's not just gonna like siphon all your funds away. On the bad side, you have hackers that are analyzing it all the time and breaking it. And the thing with this kind of exploitation is, you can, just like in a traditional software exploitation context, you can go download the software yourself, right? And then fuzz it locally and try to find overflows and things like that. You can do the same thing with smart contract code. You can deploy it to your own local test network where it never touches anything public, right? And test exploits against it locally. So what attackers do is they'll go download the public code, deploy it to a local blockchain, and then test exploits from there. All right, so common Web3 attacks. So how do these smart contracts actually get hacked? Now, each one of these we could dive into a lot. So Tyler, feel free to like jump in and ask me any questions about any of these that I may have missed, but these are some of the main ones.
I think just running down them, like there are so many avenues to run down with these, and really, again, the big thing to remember here is a lot of these go back to our early like 90s, some of the traditional vulnerabilities. It's just using different technology, different terminology, and maybe a little bit methodology, but these are not super difficult to go do or find or even research. So don't let it be too daunting to where you don't go and look at it. It is really digestible if you're into the security space at all. Like this is something that just about anybody can kind of get involved in, and we need a ton of people around here. So that's the takeaway from some of this.
Yeah, absolutely. Yeah, and I mean, so like Tyler said, a lot of these are similar issues, but the thing that I find fascinating about smart contract vulnerabilities is there is a unique vulnerability class that is manifesting itself, like completely different from your traditional software development vulnerabilities, traditional web app vulnerabilities. Smart contracts do have extremely unique vulnerabilities that you won't find anywhere else. And I'll talk about a couple of these here in this slide. So super common in all of security, right? Access control. Like this is one that is, you know, something that every piece of software has, right? Like it should have. So with smart contracts, you can actually program in access control. So in a context of I'm an owner or an administrator of this contract, therefore I can do administrative functionalities. So that kind of thing can be programmed into a smart contract. For example, let's say that like I wanted to create an exchange, a decentralized exchange, and I wanted to have the ability to you know, transfer tokens from one wallet to another if I needed to. It's not something that, you know, a lot of users will want you to have, but let's say that for the sake of me, you know, having that extra ability, you can program it in so that only my wallet address as an owner of the contract can do something. Now, a lot of times, what access control actually gets used for is things like if you have a DAO, so a decentralized autonomous organization. This is another very much blockchain specific thing where you have the ability to create voting rights based off of you know, holders of a token, so to speak. So let's say that I only wanted the holders of my token to be able to vote on a proposal. So I would create an access control rule that only allows wallets that hold the token to vote. Otherwise, anyone could vote. So that's one thing that we see sometimes where access control issues have not been put in place. And you know, anyone can go and move funds around, or they can drain a wallet, things like that. Oracle manipulation. This is actually a really interesting one because this actually involves real world non-blockchain assets. Now, if you think about blockchain code, right? The blockchain itself doesn't have any insight into real world data like the weather or the price of a token even, right? Like it's all managed within the storage that has been set on the blockchain. So there's no like constant feed of like where to get that from, unless they actually call an oracle, which is an entity that lives on the internet somewhere, creates a point of centralization, and a lot of exploits have happened where you as an attacker can manipulate the price of an oracle. So like let's say I knew this contract was checking Security Weekly's podcast feed for the price of Ethereum every day or something, there was an API there, and I went and I just DDoSed that feed, right? What happens to the price feed? Like that's the kind of thing where Oracle manipulation can come into play.
It's almost like shorting stocks or leveraging insider trade to short stocks in a sense at the digital level. And keep in mind, all of these are just smart contract or code-based attacks. We haven't even touched on some of the other attacks that we will get to. I know there's questions around some of the social engineering, VoIP attacks, leveraging fake user IDs of projects, the traditional development side of how these contracts are deployed. This is actually just exploitation of code and bytes and bits happening.
Reentrancy. So this is one of the ones that I find very much a smart contract specific vulnerability. Like you really don't see this anywhere else. So the idea of reentrancy is, let's say I have a function in my contract where I can transfer value from a user's wallet to my wallet, or withdraw. Let's say it's a withdraw function where I'm withdrawing. You know, I have Ethereum in this contract, right? Like I've staked it. Maybe it's a staking contract, and I'm going to withdraw the funds, right? Now, if that contract logic has me withdrawing the funds, but then calls another piece of code that I can control. Like for example, if it tries to call something that I can specify, you can do something called reentrancy, where you actually re-enter into the same code prior to the balance actually ending up being updated. So what'll happen is, like, it'll say, oh, I want to withdraw 1 ETH, but then I'm going to call this other thing. Oh, it goes back into the same function. Oh, I want to withdraw 1 ETH, and it just continues and loops through the entire balance of that contract until the entire thing is just drained. So that would be like a reentrancy example. Integer overflows and underflows. So this is something that has kind of been fixed in some of the later versions of Solidity compiler. But for a long time, a lot of Solidity code was vulnerable to overflows and underflows, where you could, you know, go past the high register of a uint 256 and roll back over under to, like, you know, 1.
This was like the early development life cycle that we'd seen in like early exploits, kind of the same problems. Now they've fixed some of that with the compilers and networks they're deployed on. But yeah, that one was early on. That one was crazy.
Yeah. Front running. This is something that's still a big problem. So whenever you submit a transaction to any blockchain, what'll happen is, before it gets picked up by miners to go and validate that transaction, it sits in this kind of like purgatory of transactions called the mempool. All right, so this is before a miner says, oh, there's a new transaction, let me go check that out and go make sure that's valid. So it sits in this place called the mempool. And the thing about the mempool is anyone can visibly see what's in the mempool. So if I'm an attacker and I want to see a transaction that's in the mempool, I could just be watching the mempool, take whatever transaction was there, and then try to submit the exact same transaction, but with a higher gas fee. So in Ethereum, you have these things called gas fees. And gas fees are basically the transaction fees that you pay the miner to say, hey, thank you for processing my transaction. You know, this is your fee for doing so. Now, the thing with mining is they pick up whatever the highest gas fee is. So they're incentivized to mine the highest gas fee first. So a good example of this type of attack would be like a game where I am trying to solve a puzzle, right? And in order to win the prize, I have to submit a transaction with the answer to the puzzle contract, right? Now, if I'm an attacker, I can just listen for anyone submitting that answer and then copy that transaction, resubmit it, but with a much higher gas fee, and then beat them, and I would be the one winning the prize. So front running is an attack currently that is
I still don't think they have that figured out or fixed yet.
It's not figured out
yet. I don't see a good way to fix that.
Yeah. But you know, like trying to implement some logic around mitigating risk with front running is something that a lot of contracts try to do.
Securing some of those gas fees and putting some crypto around like the transaction submittal process. Like I think those are going to be things we see in the future.
Yep, for sure. Now, those are smart contract attacks. This one involves smart contracts, but is more on the consumer side of like the phishing perspective or phishing spectrum. So with Ethereum tokens, so whether it's an ERC20 token, so like a typical cryptocurrency type of coin that you see a lot of, or in ERC 721, which is an NFT, 1155 are also NFTs. Those tokens have their own contracts. Now, most of those contracts have functions for setting an approval for somebody else to send on their behalf. Now, a lot of legit exchanges use this functionality so that they have the ability to transact coins within their own pool of coins to other users. So if I'm going to trade Ethereum for another coin, I would go to an exchange like Uniswap or SushiSwap, and then set a token approval so that exchange has the ability to transact on my behalf. Now, this gets misused by attackers where they will create a phishing page that trick you into going to this malicious approval transaction, where if you approve for a malicious contract to have the approval to send on your behalf, that means that they can effectively transfer everything out of your wallet, or transfer whatever you've approved for that matter. So we've seen a lot of attacks where what'll happen is they will either drain all of that specific token, or they'll take all the NFTs from that same collection. One good place to check pretty often is this site called Revoke Cache. This can also be done on Etherscan, but you can actually go there and check what approvals have been made by your wallet. And then you can see, oh, hey, this random contract address has full approval on my whatever token. So that's one of the things we see pretty often. Administrative issues.
Approvals on. I said I didn't know you could actually see the approvals on that one for the permissions.
Yeah, so I definitely hit up Revoke Cache pretty often just to double check, but and you can also revoke those privileges there too, which is nice.
Oh, that's really nice. Does that allow things like flash bots where you can actually set secondary contracts to go and do the revoking on your behalf in like race conditions? Oftentimes you have what's called freezing. You've got timeouts where certain contracts or certain transactions have security precautions in place, something like you have to have 7 days in order to unthaw a wallet so that a large transaction can be approved from like a main wallet. During those, if there's some kind of scam or something, that safety mechanism, I've seen many attacks where the seed phrase is compromised and you end up having to put flash bots in place that is essentially code on code to go and do a bunch of revokes or do a bunch of transfers and try and do the race condition to beat whoever stole your seed. Once that thaw happens, they go and try and drain your transactions or use your wallet. That is kind of where some of this revoke stuff, you can think about other code that's going to apply to you where you're trying to conduct actions against your wallet, or things like Revoke Cache, what's going to be an API call that's going to be leveraged in order to do that revocation on the permission. So those are important things to keep in mind when you're starting to think about not only the attack side of this, but how do you actually do protections, implement some of the protections and safety mechanisms, as well as utilize those to help your clients if there is some kind of a breach or issue with a smart contract.
Yep. Yeah. And I mean, in that case, like if the tokens were locked, right, like you would be able to go to like Revoke Cache and revoke that permission, right, prior to it unlocking and then transferring out. And the thing that's that's kind of like a little difficult to wrap your mind around when you think about token approvals is, at the end of the day, it's not actually something that is tied to your wallet specifically. And at the end of the day, tokens, even though it says that you own those tokens, like for example, WETH, wrapped ETH, is a very common ERC20 token that is meant to mimic ETH. These ERC20 tokens, ERC721 tokens, these are things that are not necessarily stored in your wallet, so to speak. These are things that are actually pointers from a smart contract that says that you own something at the end of the day. And so when it comes to token approvals, the approval is not something that is literally in your wallet, like that is manageable by by changing something in your wallet necessarily. You actually have to send a transaction to that smart contract to say, I am revoking this approval, and then it is stored in the storage of that contract that you have taken away with that approval. So it's one of those things. It's a little bit weird to kind of wrap your mind around. It's kind of like a reverse kind of like firewall way of looking at things. Like you would think like, oh, well, I have my wallet right here, I should be able to just like firewall it off from sending any transactions, right? But no, it's more like, oh, I have my wallet, this is the key to where the tokens actually are, and I should make that change there.
Crystal clear for everybody, right?
Yep. So I mean, this brings us up to private keys and how they're stored. So centralized exchanges, if you go and sign up for like a Coinbase account or Binance account, they control your keys. So if you're buying Bitcoin on Coinbase, you're buying Bitcoin on Binance or Ethereum or on either of these exchanges, they control the keys. So if Coinbase gets hacked, and your funds are taken out of your wallet. There's nothing they can do about it. Sure, they might be at the point now where they try to reimburse some of it, right?
They have a reputation now.
They have a reputation, but there is no obligation. There is no FDIC backing for those funds. In many cases, they're just gone. Like Mt. Gox, was one of the main first exchanges that got hacked, and once it got hacked and everyone lost their funds, that was it. There was no getting it back.
That was a big one.
Yeah, so when we talk about like not your keys, not your coins, that's what that means. So how do you store your own funds? In many cases, you should just transfer off of those exchanges into your own wallets you control. Now, this is where use case and like user experience comes into play, right? And this is something that, like, if I try to get like my mom or my dad to install, a MetaMask wallet and then back up their recovery phrase, it's not something that's super streamlined at this point, right? It is a little bit more difficult than just saying, hey, log into your bank account. So software wallets are probably the easiest thing outside of storing it in an exchange currently, right? Depends on risk level though. Hardware wallets would be like the next layer of defense, right? Like actually storing your coins in a hardware wallet. Browser extensions. So software wallets are like actual full pieces of software on your computer, like actual like GUI clients, right? But a lot of the way people interact today are through browser extensions.
Hey, Beau, I wanted to ask you, what do you recommend for a hardware wallet, you and Tyler both? Like if you're on Amazon, I search for hardware wallets, there's a lot of options.
Yep, yeah, so I'm a big fan of both the Ledger and the Trezor. Both of those have been pretty tried and true at this point. They have gone through a lot of attacks. Both have had their own issues, but just like like the age-old discussion, like what's better, Windows or Linux or Mac or whatever, like what's more secure? We're at the point now where like Windows gets attacked so often every day that actually Windows security is pretty good. And that's kind of the same thing here, right? We have the two major stakeholder hardware wallets that they get attacked constantly, and both are pretty good. At the end of the day, if somebody steals your hardware wallet and they have the skills to do like chip off
yeah,
removal, that
skills
kind of
with
stuff.
a soldering iron, you might be in trouble.
Yeah, and so here's the defense against that, right? So let's say somebody steals your hardware wallet. Have a backup hardware wallet, right? And so you don't even have to store the keys on it, right? Like, so for example, like let's say you have a Ledger hardware wallet, buy two of them, put one in your closet somewhere that you don't actually have the seed phrase stored on at all. It's just a backup. And then in the event that somebody stole your hardware wallet or you lost it, you can immediately just go back up right to that new device using the mnemonic recovery phrase.
Mm-hmm.
Right? Your mnemonic phrase, I feel, is actually almost more important than your wallet is at this point.
Absolutely.
Hardware wallets are 100% like, get a good one. The Trezor and the Ledger are the two I use. However, I've went and bought several of the mnemonic, still encased key phrases, and I put them in very strategic locations now, because if your house was on fire.
You know those locations, Tyler?
I remember those locations after the last bit. Yes, I know where those ones are. But the use case is important, right? Like if your house is on fire, think about your risk profile. Like if your house is on fire, yeah, they'll recover it. You can eventually get to it. It's probably not going to be fully damaged, but that's going to take a while. If you need funds out of there and you use it consistently, then that's a problem. You want to have that in another location that's easy to get to. You can provide that to someone you trust, put it in a bank, whatever you want to do there. You think about chaos and unrest though, and your ability to get to that bank and pull it out of there if something happened and your house got burned. That's a different risk threat profile, right? You have to think about your use cases and what's your worst disaster recovery possibility. And that same thing goes for your wallets. Like there's a convenience factor. I have hot wallets and software wallets. I leverage those with the debit card. If I need to pay someone in Bitcoin or I'm buying something that only uses Bitcoin, I've got a limited number of funds tied to that Bitcoin and that hot wallet and that app, and I use those for specific things. And I have a different software wallet for other things, different exchanges for doing investments or buying NFTs. That's a separate hot wallet. Then you've got your MetaMask that's on your phone, and that's leveraged for maybe instant transfers. Beau and I are at a conference, I need to pay him, I can, kick him some crypto real quick, and that's all secure private transaction between the two of us. I have certain friends that are really paranoid, so we leverage some of those mechanisms. And then you've got your investments in like where you're putting the bulk of your transactions and money and access to that money on something like a cold wallet or hardware wallet. Those are, multiple stages at Defense in Depth, really looking at your use cases and convenience, because there are things that are inconvenient about doing this, but getting that strategy right for you becomes very important. At the end of the day, you really want to make sure that anything that is on a hot wallet or an app or in an exchange is something you're comfortable with losing, because that is always a possibility. And that's where the hardware wallet, things that I cannot afford to lose, go into something like a hardware wallet, and I have a backup and disaster recovery plan for that hardware wallet.
Yep. Yeah, absolutely. Yeah, I think taking a multi-wallet approach, just like you described there, is the best way to do it, for sure. Like you have your long-term cold wallet, you never touch unless you absolutely have to. That you just store, the majority of like a savings account, right? And then you have, your daily spender kind of a thing on your phone. Yeah, absolutely. Multi-sig wallets. This is where you can create an additional layer of security on top of hardware wallets, though, too. So you can actually create wallets that require multiple signatures from multiple entities. So, like for example, let's say that Tyler and I started a business and we had a single joint account. We could create 5 separate wallets, give 3 to other people, and me and Tyler could, have a setup where 3 of the 5 of us have to sign a transaction for it to go through. So that's what like a multi-sig wallet would be, basically, where you have a a situation where you say a certain number of certain people have to be able to sign this transaction.
It's like having multiple signatures on a check. You have your CFO and your CEO both have to sign this transaction in ACH. Like, this is where business processes actually in the real world make a lot of sense for how blockchains and DeFi are beginning to utilize things like multi-sig wallets for larger transactions.
Yep. Yeah. So on top of the the Web3 stuff we've already talked, like the Web2 security risks still exist, right? So phishing is huge, right? Like still a huge risk. Some of the scams that we'll talk about on the Discord slide here in a minute, like it's gotten so bad. like I mentioned earlier, Discord has become like the #1 place for most crypto projects.
And support.
And IT. I mean, like, look at us. Like, we have like, I don't even know how many InfoSec Discords we're in at this point. But yeah, so phishing still huge. Scams are huge. Like, that's one of the things that I really dislike a lot, because I think that a lot of really smart security people, they see all the scams happening. They see the 95% of things happening in blockchain. They're like, oh, it's just all scams. Why should I bother? Why should I bother caring about it? But there are some legit projects out there that are doing some really interesting stuff with smart contracts and blockchain tech. We're here to talk about centralized exchange attacks, SIM swaps. Now, this, I don't know, did you guys listen to Jack's episode, Jack Reciter, Darknet Diaries from it's a couple episodes back?
Where he all his episodes. He talks a lot about the Discord hacks. He talks a lot about SIM swapping. He's covered it in a few episodes, I think, really well.
Oh yeah. So Jack's a buddy of mine, and we talk about it all the time.
Yeah, he's great. He interviewed and he caught some flack for it, like a younger kid that was doing these SIM swapping things. I mean, he dug him up and interviewed him, which I think is great. I mean,
oh no, yeah.
We don't do that kind of stuff here at Security Weekly, right? So I'm glad he's he's finding the actual cyber criminals and talking to them, which I think in this case is really important, right?
Yeah, and I mean, like, so the thing that fascinated me about that story, though, is like you always hear about SIM swaps and like calling up the mobile provider and saying, hey, I'm I'm Beau, and I want to switch my phone over to a new phone, or my number over to a new phone. Like that's like the common scenario that you hear a lot of. But the story that kid described in that episode was there's like a team of kids where they now have a car, and they drive up to like a Verizon and they run inside and then like steal the tablet from the manager and try to switch it over to a new phone.
And they figured out like what the time window was, because like Verizon and AT&T caught on to that, and they were like, well, if you go steal a tablet and they realize it's missing, there's a procedure that they have now. So their time window is like, I don't know if it's minutes or hours, or it varies per provider. And then they're relaying that information from that tablet from like a whole team of people, like you said. So there's like the holder, and the holder is the number, holds the phone of the number you're swapping to, so that when you do the two-factor, the number gets relayed by the holder, right? So they spread it out across this whole team. It's really fascinating how it works. And then those episodes I don't know what the episodes are, but if you dig, you'll
Oh yeah, yeah, it's so good. But yeah, so why does that matter to like the crypto world, right? So, you know, if you're storing your funds on a centralized exchange like Coinbase, and somebody's able to swap your phone over to their phone, and they have your password, they have all the things they need to get into your account.
Right. So don't use your phone. Don't use your phone if you're protecting a cryptocurrency account.
Yeah, that's
I'm
yeah,
sure
absolutely.
that must be an option to most providers, right?
Or don't, at least don't use your phone number, right? Like, so, you know, using like an authenticator app
Yes,
would be a better
exactly.
solution. So yeah, and in those cases, like if you get scammed, you know, you send all your funds out, like they're just gone. There's nothing you can do about it.
Right.
All right, so Discord hacks. This is something, honestly, like I want to do an entire webcast just on Discord hacks, because like, I mean, just like you said, Jack's been talking about it. Like I've been watching it happen for the last year, and it's insane. Like just the extent of which Discord can be hacked. Like most people don't realize it. So how bad? And the reason I think like so many hacks have kind of came about is because with all these crypto projects now in Discord, it's very easy for an attacker to play off of the feeling that most people have. They're like, they want to be first to something, right? Like, so in the case of like an NFT drop, right, super high, like high profile kind of thing, where if somebody drops a new NFT, like you have 10,000 people racing to mint it as fast as possible. So in those cases, what an attacker will do is they'll hack a Discord, and then they'll just post a message in that Discord like this one that says, hey, you can mint at this link. And then people are just like, you know, aping into it, and they just like click and they just go mint. And what ends up happening is it's a, you know, a wallet draining type of thing where they do token approval, like I mentioned earlier, or they install a piece of malware. There's a lot of things that can kind of happen there.
I've seen one where they offer support, or they're trying to mint something and it's not working, and so they'll have taken over or mimic one of the support technicians. With a lot of these Discord servers have people on the exchange or on whatever blockchain there's a support channel. They'll either take over a support account, or they'll change the icon and make the name the exact same. It just has a different number at the end of it. They'll be that support person, and they'll post a link. Okay, if you're having issues, go to this, revalidate your seed phrase. That's one that, you know, some of the stuff I sent you, there's an entire setup. It looks just like the block. They're having an issue with, you know, something they're trying to mint. They'll go and insert the seed phrase at this malicious site. That actually is a bot that then does a flash drain based on the seed phrase and takes over that wallet. And that's all from social engineering, just looking like a support technician, looking like someone on the exchange, or someone that's trying to drop an NFT, and they're offering, you know, support as that NFT artist or whatever. All of those social engineering things play into that. And it's all through Discord, almost always.
Almost always, yeah. So one of the bigger things or one of the more, I guess, like primary things that happens a lot is webhook compromise. So with Discord, you can create these webhooks where it's basically a URL that if you post to that URL, you can make, you know, things happen in the Discord. And so, you know, if that URL is compromised, then whoever controls the URL can, you know, send messages in your Discord. So that's one of the more popular ones. Admins getting phished, right? So just, you know, traditional cred phishing type of attacks against admins of Discords happens all the time. One of the bigger ones is OAuth session attacks, right? So we do this on red teams with, you know, O365 like illicit consent grant attacks, like where we're creating like an OAuth consent page where we try to get access to a user's account by getting them to consent to certain permissions within their own O365 account. Now, the same thing can happen with Discord. So with Discord, you can create an OAuth app that has permissions to do things on your behalf. So what attackers will do is they'll create an OAuth app that has administrative permissions, and they'll convince an admin to just click through the accept permissions of a, you know, a link that they send them. And then
those are the scary ones, because you're relying on someone else at that point in the Discord, the admins of the Discord. You're relying that they're savvy enough to do the right thing, and the bots and that Discord server aren't compromised.
Yep. Another big one is just direct message scams. So in Discord, you have the ability, if you right click a Discord and you go to server settings, or no, I'm sorry, not server settings, privacy settings. You can click the checkbox to allow direct messages from server members. So by default, that's on. So anytime you join a Discord server, anybody in that Discord can direct message you by default. So anytime you go to join a new Discord server, always check that privacy setting and just disable that ability to direct message you. Otherwise, anyone in that server can DM you, unless you trust the server and you know people there, you don't mind DMing you.
Don't do that on Security Weekly. We all want to DM.
Yeah. So that's something that, you know, if you don't change, what'll happen is you'll jump into a Discord and then you'll immediately get a DM from somebody who looks like the server themselves, right? Like they'll have the profile picture of the server, they'll have the name of the server, and they'll, you know, try to trick you into doing something. And then bot services compromise. So this is one that happened a week or two ago, where the Me6 bot, which is super popular bot, the admins themselves, the admin service, got compromised, and it was used to publish these phishing scams in like 100 different Discords, and that was because the bot itself had a centralized storage location or management location.
That one was terrifying. Like the spread that one had quickly, like that was some of the stuff I sent you that we were working on. Like that was directly where that came from, and that was widespread across multiple exchanges.
Yeah. All right, so we're up to the start hacking section. Some resources to get started. So I have a few favorite things, and Tyler, feel free to chime in on like your favorite stuff too. But like for me, honestly, like this book, Mastering Ethereum, like I just sat down and I read like this cover to cover when I first started really diving into like Solidity and wanting to understand the entire ecosystem. And this for me was like the main thing that just made it click. And the cool thing about this book is it's open source and you can just go read it on GitHub. You don't even have to buy it. There's also hands-on smart contract development, which is really good. And then Mastering Bitcoin is the other like sister book to this, which is by the same author.
I agree. I was looking for on Twitter. It's Fiction is with the 0 on the end. Fiction, and there's one other guy that has put out some great contact on smart contracts. They actually have a whole series. It's Console Cowboys. That's what it is. They have a whole thing, and I'll drop this in Discord. They have a whole series that they've offered for free that gets super deep on DApp and smart contracts, all the logistics things. They had a whole YouTube and Vimeo video series that went start to finish from like basic to advanced, and it's all free. Like these guys were dropping some serious stuff. So I'll drop that in Discord as well. That's one of my favorite series I've watched.
Nice. So Solidity coding. So getting started with Solidity, it looks like a game and it looks like it's probably made for kids, but cryptozombies.io, it's actually really fun.
Someone said that was really good.
It is. It's really good. Yeah. So it's a free DApp building game. It is fun, and I think like, you know, you can have resources that get like really in depth and can be overly like too much information. This is, to me, like it gives you just enough information to go get started. So I recommend doing this. It's free. Solidity by Example is another good site to reference. There are, you know, plenty of paid resources out there too. There's a lot of Udemy sites or Udemy classes, that kind of stuff. But the one that I did last year was this Consensus Blockchain Developer Bootcamp. I found that one to be pretty good. I think it was a little less than $1,000 for that one. Ctfs. So, you know, I'm like a huge advocate of Ctfs in general. And so that's one of the things that I always find I learn the best whenever I'm challenged to figure something out, like that's a problem, like a puzzle. So Ethernaut is one of the main Ctfs you can go do. It's super easy to set up. All you need is MetaMask wallet. So you create a MetaMask wallet, you log in, you can start hacking away. Super easy to get going on that one. Capture Ether is good. Damn Vulnerable DeFi is really good too. Very similar to the other ones. definitely recommend checking those out if you are interested in just kind of getting started with the hacking side of things. On the bug bounty side, all right, so Immunify is like the HackerOne or the bug crowd for blockchain bug bounties. And if you go to immunify.com, you can see like the multi-million-dollar bug bounties that are out there. Let's see, I'll pull it up real quick. So immunify.com. So can you see the browser okay here?
Yes.
All right, cool. So like if you explore bug bounties here, you can see, I think you can sort it by the highest payout too. Yeah, price, high to low. So like check this out, Wormhole, $10 million rewards up to. MakerDAO, rewards up to $10 million. Chain, rewards up to $5 million. Like the amount you can make off of doing bug bounties on a lot of these projects is just insane. Like many of these are over $1 million, right? So yeah, I mean, if you're interested in doing any sort of like smart contract hacking, and some of these actually include more than just smart contracts. You can see here, you can see like, so this one includes smart contract, but also websites and applications. So like if you were to view that bounty, walks you through traditional bug bounty, rules of engagement, scope kind of stuff, right? And what types of criteria are required to make $1.5 million off this. But people do it. People actually, like, I've seen multiple people make $1 million bug bounties off these.
I really should start doing that. Like, obviously we've not done that because I'm still here, but
we got time. We don't have time, man. We're
yeah,
making
webcasts. I guess other stuff is taking precedence of $10 million.
See, the way I see it is, if I can convince like 1 or 2 people on this webcast to go do it, then I've done my job. So yep. they can make the ecosystem more secure. So yeah, there's a few other ones too. I actually made a quick start guide that I put together last year called Blockchain Hacks. It's basically, it walks you through setting up a MetaMask wallet, downloading Ganache, which is a tool for deploying a local blockchain, deploying your first couple smart contracts to it, and then using some of the security analysis tools that are out there. So there are a few different security analysis tools for smart contracts, kind of like your Nessa scanners and map scanners, but for smart contracts. So you have Slither, which is one of the more popular ones. There's MythX, which is another tool for doing automated scanning. But it kind of walks you through just like that general kind of getting set up if you are interested in getting set up to do it. All right, so some key takeaways from today. Use cases for blockchain are growing significantly. We talked about Walmart implementing supply chain tracking. Lots of different coins out there, lots of different use cases that are being developed. Hacks are resulting in crazy loss of funds, just absolutely massive amounts of money being stolen every day. Smart contract hacking is still in its infancy. So, like Tyler mentioned, there's only a few people that do this. There's only a handful of organizations that actually do smart contract audits. And even fewer just general like bug bounty people that are out there doing it. So there's a huge market for security people to come in and try to help secure this ecosystem. As new blockchain implementations are developed, new hacks will too. So as protocols change. So like, for example, we were talking about how Ethereum is moving to proof of stake, right? So it's ETH 1.0 is moving to ETH 2.0. I'm sure there's going to be something from a vulnerabilities perspective that comes out of that, right? And that's pretty much it. I don't know, Tyler, I don't want to end it, but what do you got?
No, that's great, man. I mean, again, appreciate you like putting together some fire slides and covering like all the basics that I was just going to chat through. You actually did it in a much more methodical.
We can go back. Oh, we can chat more.
It was really good, and honestly, if anybody is interested, or you do have an organization that's looking at smart contracts, looking at things like the blockchain, you need consulting. Like, again, the shameless plug for Beau here, Black Hills is starting to get into that very heavily. There's not many companies that have the security appetite to do that. Really, definitely check them out. Put some links in Discord as well to some of the other resources that I follow and some places that are doing some interesting things. So reach out. There's when crap hits the fan for blockchain and crypto and smart contracts, like there's really not that many places you can trust or call, because there's a lot of scams on, recovering your stuff as well. So really make sure you have a trusted partner in that avenue if that's something you're looking at and thinking about doing from an organization standpoint.
Absolutely.
Awesome. Well, guys, thank you so much. And Beau, just remember your podcast. Where can people find that?
Yeah, so that's just coinsecpodcast.com. Here, I'll throw that in here too. So yeah, so weekly, we do a podcast where, well, I say weekly, we try to do it weekly, where basically we just talk about all the hacks and security issues that have happened in all of the blockchain space. And I mean, to like put that in perspective, right? Like, I mean, the fact that we can do an almost weekly podcast where we can talk about multi-million-dollar hacks,
Yeah,
like it's
right.
it's such a niche thing, like blockchain security to have a podcast for, but
Awesome.
it's fun because I get to see some of the the latest hacks that are happening, get to talk about like some of these unique vulnerabilities that are coming out. But yeah, that's CoinSec podcast.
And do we have a question? Because we're giving away a $100 gift card, which I forgot to mention at the top, but we're giving away a $100 gift card to Hacker Warehouse. So hopefully people are still tuned in. And I guess if you tune in, you stick around to the end, you get a better chance. You're going to put your correct answer. So you guys have to monitor the Discord in case I don't know what the correct answer is, which is pretty good probability I don't know what the correct answer is. So the first person to respond to Discord with the correct answer to the question that Beau and Tyler look like they're thinking about what the question should be right now. I know we talked a little bit.
I do have it. I was looking
Okay.
for the proper answer. Let's see. Okay, here's a good one. What is the name or song of the of the horrible cringe rapper that stole billions from Bitcoin? The DOJ seized.
That's a good one.
Yeah, I don't remember the name or the song of that. And you told me, Tyler, you're like, don't listen to it, Paul. You'll be scarred for life.
Forget it once you see it.
I gotta go listen now. And then I was like, oh my God, I'm scarred for life.
So you say, what is the name or song? But like, whenever that happened, I watched all their songs, every single one.
Oh my gosh.
Oh yeah, somebody got it.
Is that the right
right answer? I don't know.
Yep, that's it. I mean, we'll take that one because that was the nickname that she was given.
Yeah, Razzlecon.
Razzlecon, yeah. Hey, help desk guy wins the gift card.
Stewart.
Crocodile of Wall Street girl. Yes.
If you've not watched that, we'll post a link to the horribleness.
Oh, don't watch it. No,
oh no, you must watch it. You have to watch it.
You have to watch it. Then you're gonna go listen to a bunch of '90s rap to cleanse your mind.
So good.
It is pretty horrible. No, that's awesome. That was the right answer. And if you've not read that article on the DOJ seizure of that is a fascinating and a great example of why it is hard to wash those particular funds. So
it's also a great example of not to store your crypto digitally anywhere, because they store their private keys to $4 billion worth of Bitcoin in Google Drive.
Dude, that was probably my key takeaway. Like, as I watched several of these seizures from DOJ, I'm like, how did they actually see? Like, where did they go to get the wallet? And I'm like, they broke into the computer. They seized the computer. It's sitting on the damn computer hard drive. Like, or in this case, it was on Google Drive. They just took over the damn account. Like, that's horrible. Like, $4 billion on Google Drive. You trust Google that one?
No. Well, Beau and Tyler, thank you so much for your presentation today. It was awesome. Great discussions, great interaction with the community. So thanks again.
Anytime.
This will be posted to YouTube, so we can we'll share it out.
Sweet. Awesome. Yeah, thanks for having me so much. Had a blast.
Awesome. Thanks, Beau. Thanks, Tyler.
See ya.